Hey everyone, my name is Hust. You're on my channel. Here's 50 facts about the sun. Subscribe and let's go. Fact number 1. 4.6 billion years ago, the sun formed from a collapsing protostar within a vast gas and dust cloud. As its core temperature rose to 27 million degrees Fahrenheit, nuclear fusion began, converting hydrogen into helium. This process releases 3.8 times 10 to the 26 power watts of energy, equal to the detonation of 1 billion hydrogen bombs per second. This energy sustains the sun's luminosity and drives life on Earth. The sun is composed of approximately 74% hydrogen, 24% helium, and less than 2% heavier elements, including oxygen, carbon, and iron. These heavier elements are critical for forming planets and life. Spectroscopy, which studies the light emitted by the sun, helps scientists uncover its chemical composition and understand its evolution over billions of years. The sun's diameter spans an enormous 864,938 miles, making it 109 times larger than Earth's diameter, while its radius is 432,469 miles. The sun's vast volume could contain about 1.3 million Earths. Surface temperatures reach 9,932 degrees Fahrenheit, and its core exceeds 27 million degrees Fahrenheit, a testament to the sun's immense heat and energy production. The sun's mass is a staggering 1.989 times 10 to the power of 30 kilograms, accounting for 99.86% of the solar system's total mass. This massive weight generates a surface gravity of 890 feet per second squared, which is 28 times greater than Earth's. This gravity governs the motion of planets, asteroids, and comets, maintaining the stability of the solar system. In the sun's core, 600 million tons of hydrogen fuse into 596 million tons of helium every second. The missing 4 million tons are converted into energy, powering the sun. This energy travels through the radiative zone over millions of years before emerging as sunlight, which takes just 8 minutes and 20 seconds to reach Earth. The sun's rotation is uneven due to its gaseous nature. The equatorial region completes a rotation in 25 days, while the poles take about 35 days. This differential rotation twists magnetic field lines, leading to the solar activity cycle, including the formation of sunspots, solar flares, and coronal mass ejections. The sun's corona, its outermost layer, is perplexingly hot, with temperatures reaching millions of degrees Fahrenheit, far hotter than its surface. Scientists attribute this to magnetic reconnection and alpha waves, which release energy into the corona. These mechanisms remain an active area of research to understand plasma physics. The solar wind, a stream of charged particles, travels at speeds between 900,000 and 1.8 million miles per hour. It shapes the heliosphere, a protective bubble that extends beyond Pluto, shielding the solar system from galactic cosmic rays. This interaction also generates stunning auroras when particles collide with Earth's atmosphere. Sunspots, appearing darker due to temperatures of about 7,232 degrees Fahrenheit, are caused by concentrated magnetic fields that inhibit heat flow. These spots can measure over 50,000 miles in diameter, making them 6 times larger than Earth. Their number varies with the 11-year solar cycle, marking peaks of solar activity. Solar flares are powerful explosions of energy that release the equivalent of 10 billion megatons of TNT in minutes. These flares emit X-rays and charged particles that travel to Earth, potentially disrupting communication systems and causing geomagnetic storms that interfere with power grids and satellite technology. The sun's corona, visible only during total solar eclipses, extends millions of miles into space and reaches temperatures exceeding 1.8 million degrees Fahrenheit. Spacecraft like the Parker Solar Probe have ventured within 3.7 million miles of the sun, uncovering secrets about the corona's extreme heat and its impact on the solar wind. The sun's magnetic field originates in its turbulent convection zone. As plasma rises and falls, it twists magnetic lines, creating powerful fields. These lines often reconnect, releasing massive energy as solar flares and coronal mass ejections, which can interfere with Earth's satellites and communications. The Sun is currently in its stable main sequence phase, where it has been for 4.6 billion years. It converts hydrogen into helium through nuclear fusion. In approximately 5 billion years, it will expand into a red giant, consuming inner planets, and eventually shrink into a white dwarf, marking the end of its life cycle. Total solar eclipses occur when the moon aligns perfectly between the sun and Earth. The sun is 400 times larger than the moon, but also 400 times farther away, creating a perfect match in size. This alignment allows us to see the sun's corona and has been crucial for studying the sun's outer atmosphere. Light from the sun takes a complex journey through its layers before reaching Earth. It passes through the photosphere, chromosphere, and corona, each with unique characteristics. The chromosphere, for example, produces spicules, jets of plasma traveling at 156,000 miles per hour, contributing to the sun's outer dynamics. Photons created in the sun's core take 1 million years to escape the dense radiative zone. Once they reach the surface, they travel 93 million miles to Earth in just 8 minutes and 20 seconds, providing the light and heat essential for sustaining life and driving Earth's ecosystems. The sun loses billions of tons of material annually through the solar wind. While this seems significant over its 10 billion year lifetime, the sun will lose less than 0.03% of its total mass, a change too small to disrupt the solar system's balance or its gravitational pull. The sun's 11-year solar cycle sees its magnetic field flip polarity, causing sunspots, solar flares, and ejections of charged particles. During the solar maximum, these phenomena peak, affecting Earth's magnetic field, communication systems, and even power grids, demonstrating the sun's influence on human activity. The sun's photosphere, its visible surface, has a temperature of about 9,932 degrees Fahrenheit. This layer emits the sunlight that reaches Earth and powers life. Variations in solar output during the sun's cycles influence Earth's weather, climate, and atmospheric dynamics, underlining the sun's role in our environment. The sun moves through the Milky Way at 514,000 miles per hour, completing one orbit, or galactic year, every 225 to 250 million years. Since its formation, the sun has completed about 20 galactic years, showcasing the immense scale and timescales of our galaxy. Coronal mass ejections are massive expulsions of plasma and magnetic fields from the sun's corona, traveling at speeds of up to 7 million miles per hour. These ejections can release billions of tons of material, and when they interact with Earth's magnetic field, they create geomagnetic storms, disrupt satellites, and produce vibrant auroras. The sun's core experiences pressure exceeding 260 billion atmospheres, equivalent to 3.8 trillion pounds per square inch. This immense force is required to sustain nuclear fusion, where hydrogen nuclei overcome their natural repulsion to fuse into helium, releasing colossal amounts of energy in the process. The heliosphere, a magnetic bubble created by the solar wind, extends more than 9.3 billion miles, 100 astronomical units, from the sun. This vast structure shields the solar system from harmful interstellar cosmic rays, creating a relatively stable environment for life on Earth and beyond. Solar cycles influence Earth's Van Allen belts, which are regions of trapped radiation encircling the planet. During periods of high solar activity, the intensity of these belts increases, posing heightened risks to astronauts, satellites, and even high-altitude flights due to increased radiation exposure. The sun's axial tilt of 7.25 degrees relative to Earth's orbital plane influences how solar radiation is distributed across the planet. This tilt, along with Earth's axial tilt, contributes to seasonal variations and climatic patterns, affecting ecosystems and weather systems on a global scale.